Did you know that the proof I'm about to share was once a closely guarded secret? Around 2,500 years ago, the Pythagoreans held a profound belief that everything in the universe could be represented as rational numbers. But there was a challenge to this notion. A follower of Pythagoras named Hippasus applied the Pythagorean theorem to a square with sides measuring 1 unit. To his astonishment, he discovered that the diagonal was square root 2, an irrational number that could not be expressed as a simple ratio. This revelation shattered the Pythagorean ideal and posed a threat to their teachings. Legend has it that to silence Hippasus and protect their secrets, the Pythagoreans resorted to an extreme measure, throwing him off a boat into the depths of the sea, ensuring that the truth would remain hidden. The story of Hippasus serves as a powerful reminder of how groundbreaking discoveries can challenge the foundations of established beliefs. Now, let's delve deeper into what he uncovered. Today, I will guide you through the proof of this remarkable discovery.
Now let's proceed with the proving of the irrationality of root 2. We do it by the method of contradiction. So what does it mean? In order to prove that root 2 is irrational, we first assume that root 2 is a rational number. So let us assume that root 2 is a rational number. So we already know by the definition of rational number that if if any number is a rational number, it can be expressed in the form of r by s, where r and s are integers and the denominator s is not equals to 0. Okay, now I'm assuming another thing, that r and s has a common factor other than 1. Other than 1. So if it has a common factor other than 1, I can simplify it using this common factor. That is, now root 2 is equals to r by s. If I simplify it, if I divide it by that common factor, I can get it to the form of a by b, where a and b are co-primes. Okay, so what do you mean by co-primes? Co-primes are two numbers. Co-primes are two numbers whose common factor, only common factor is 1. Or you can say in other words that two numbers whose HCF is 1 are called as co-primes. So now we got root 2 in the form of a by b, where a and b are co-primes. This a and b are co-primes is a very important point in this proof, which many students miss out. Root 2 can be expressed in the form of a by b, where a and b are co-primes. This should be noted very clearly. Now proceeding to the, now we got root 2 in the form of, a by b. I'm cross multiplying it. So I got root 2b is equals to a, squaring on both sides. Square 2 root square is 2, b square is equals to a square. So what does it mean? It means that 2 divides a square. If 2 divides a square, then 2 divides a also. Why so? We have a theorem which states that if p divides a square, then p divides a as well. So this is a theorem which is already proven. So if you have any doubt, you can send it in the comment section so that I will send the proof of this theorem also. Okay, so we got that 2 divides a. Now if 2 divides a, how can a be written as? A can be written in the form of 2c, where c is an integer. For some integer c. Yes. So what did we get? we got that a divides 2 divides a, 2b square is equals to a square, and a is equals to 2c. So if I substitute this value of a in 2b square equals to a square, let me write it as equation 1. If I substitute to a is equals to 2c in this equation, what am I going to get? I'm going to get 2b square is equals to, in place of a I'm writing 2c whole square. So 2b square is equals to 4c square. If I simplify it, I get b square is equals to 2c square. Again, what does it mean? It means that 2 divides b square. Using the same theorem, we get 2 divides b. So what did we get now? 2 divides b. Here you got 2 divides a. But what have we taken? A and B are co-primes. That is, there should not be any common factor other than 1. But here we got 2 is a common factor of both A and B. That means A and B are not co-primes. We have taken that A and B are co-primes, but we have come to the conclusion that A and B are not co-primes. So why did we get this contradiction? Because the assumption which we had taken in the beginning, that root 2 is an irrational number, this assumption seems to be wrong. Because of this wrong assumption, we have got the contradiction here. Therefore, hence we can say root 2 is an irrational number. Similarly, you can prove the irrationality of root 3 and root 5. This question is taken from Cbse class 10, chapter 1, real numbers, and it is a sure shot question, exam point of view. So try doing the irrationality proof of root 3 and root 5, and if you have any doubts, please send it in the comment section. And as always, if you have any doubts, if you are any stuck in any maths problem or English, please do let me know in the comments so that I'll make a video on that doubt in the next class. Thank you for watching. Bye bye.